Hello, Callie Daniels here. In this video, we will continue looking at some special factoring techniques, in particular, factoring a difference of cubes and factoring a sum of cubes. Now, before we get into this, I think it's a good idea to make a list of some perfect cubes. For example, 1 cubed is 1, and 2 cubed is 8, 3 cubed is 27, 4 cubed 64, 125 and 216 are perfect cubes, as are 343, 512, 729, and we've completed this list up through 10 to the third is 1,000. 1,000 is a perfect cube, okay, because it's 10 times 10 times 10. And let's also add to this list some variables, which are perfect cubes. X to the third is a perfect cube. It's the result of x times x times x. And we might say that x to the sixth is also a perfect cube because it's the result of multiplying x squared times itself 3 times. Remember that when we multiply like bases, we add those exponents. 2 plus 2 plus 2 is 6. And in fact, any variable raised to an exponent that's a multiple of 3, 3, 6, 9, 12, 15, and so on, these are all perfect cubes, okay? Because these exponents are divisible by 3, which suggests, okay, that they're the result of multiplying something times itself 3 times. X to the 12th, that's x to the 4th times x to the 4th times x to the 4th, okay? 12 divided by 3 is 4. 9 divided by 3 is 3, and so on. All right, so here we've got our list of perfect cubes. Let's proceed. When factoring a difference, okay, minus sign, of cubes, that factorization is x minus y times x squared plus xy plus y squared. Our factoring formula for factoring a sum of cubes looks almost the same as factoring a difference of cubes, doesn't it? The only thing that's different is the location of our single minus sign, right? It's either up front in the binomial or trailing in front of the second term of our trinomial. So there are our formulas, and let's practice using them. In example 3, we're going to factor each binomial. Part A, this is a difference of cubes, and we know that because m to the third is m cubed, and 125 is 5 cubed. And so as we look at our formula for factoring a difference of cubes above, we're simply going to replace each x with the variable m, and we're going to replace each y with the number 5. So when you see this binomial x minus y, we write m minus 5. And when you see the trinomial x squared plus xy plus y squared, we write m squared plus m times 5, which I'm going to write 5m, plus 5 squared, or 25. Now, here we've got our factorization, and it's always wise to check. And I'm going to go ahead and check this one. As we multiply back, m times m squared is m to the third plus 5m squared. I'm distributing the m plus 25m. Move to the minus 5, distribute to obtain minus 5m squared minus 25m and minus 125. And notice that we've got some terms in here that are opposites, and we do obtain m to the third minus 125, which is exactly what we started with, and we know we've done our factorization correctly. You can always check by multiplying back. Let's look at part B. This also is a difference of cubes. 8t to the third is 2t times 2t times 2t, or 2t to the third. 27 is 3 to the third. Okay, so we've used 8, recognized it as a perfect cube, and we recognize 27 as a perfect cube, and a variable to the third is a perfect cube. Now we just use our formula above. Okay? Everywhere you see x, substitute 2t, and everywhere that you see y, substitute 3. So we'll write 2t minus 3 times, okay, x squared, we write 2t squared, plus xy, we write plus 2t times 3, plus y squared, we write plus 3 squared. And then let's just clean up from here. 2t times 2t is 4t squared. 2t times 3 is 6t. 3 squared is 9. Okay, so our factorization, 2t minus 3 times 4t squared plus 6t and plus 9. So we move to part C. Here we've got a sum of cubes. Okay, 1000 is 10 cubed. And any variable to the sixth is that variable squared cubed. So this first term is 10a squared cubed. Okay, that's a 2 right there. And our second term, 27b to the third, is 3b times 3b times 3b, or 3b cubed. So in our formula for the sum of cubes, our second one, replace x with 10a squared, replace y with 3b, and we're looking at the right-hand side of this, right? So we'll have 10a squared plus 3b times, okay, in place of x squared, we write 10a squared squared. In place of minus xy, we write minus 10a squared 3b. And in place of y squared, we write 3b squared. And let's just clean up. As we write this, 10a squared plus 3b times 10 squared is 100. Power to a power multiply, that's 100a to the fourth. Minus, okay, so this is a 3 times 10, that's 30. A squared b, and plus 3b times 3b is 9b squared. Okay, and lastly, let's look at part D. w to the third. Okay, yeah, that's w times w times w. Let's see, 216 is a perfect cube. Okay, it's 6 cubed, and z to the third is z cubed. So this last term is 6z quantity to the third. All right, so we've got a sum of cubes. Everywhere we see x, substitute w. Everywhere we see y, substitute 6z. Here we go. So this becomes w plus 6z times w squared minus the product w times 6z plus our last term, which is 6z quantity squared. That's w plus 6z times w squared minus 6wz plus 36z squared. And again, you can check any and all of these by multiplying. Last thing that I would like to say here in regards to factoring sum and difference of cubes and how you keep track of your plus and minus symbols. In your factorization, the binomial carries the same sign as your original polynomial. So same sign. Okay, this symbol is the opposite, and your last term is always positive. So same, opposite, always positive. Likewise in part B. Same, opposite, always positive. Even for your sum of cubes, same, opposite, always positive. Same, opposite, always positive. Okay, and you might use the acronym SOAP to help you remember those signs. Same, opposite, always positive. Last thing I'd like to present to you is a summary on factoring, and this is just a really nice page to help you with any factoring problem that we've done. Okay, step 1, is there a greatest common factor? If so, factor it out. This is always your first step. Then ask yourself how many terms are in the polynomial. If there are 2 terms, check to see if it's a difference of squares or a sum or difference of cubes. And if so, factor using those forms. So is it a difference of squares or a difference or sum of cubes? Okay. If there are 3 terms, is it a perfect square trinomial? That is, does it fit one of these forms below? Okay. If so, factor it using special factoring techniques. If it's not, okay, this is where things, I believe, are the trickiest for us. Use your methods for factoring trinomials. So you might use your trial and error or that process that expands the middle term and factors by grouping. If there are 4 terms, try factoring by grouping. Okay. So here we've got a repeat of our formulas that we've used, along with this last little comment that a sum of squares, something of the form x squared plus y squared, it is not factorable unless there happens to be a common factor. Like if you see 2x squared plus 2y squared, we could factor out a greatest common factor, but that's it. Okay, that's the only case where, and actually I probably should use 4s there. Okay. Okay, because 4x squared would actually be a perfect square, wouldn't it? So if we use 4s, then we can factor out a 4. But in general, you know, something that fits that form of a sum of squares is not factorable. All right, there you go. Good luck with factoring your sum and difference of cubes, and use this final page to help you when factoring any polynomial.